We're going to go over the problems on the review sheet for compound interest. Here is the formula that's on the IB formula sheet. I won't go over the whole thing because you should already know it, but just the tricky part is this part here, the fraction. So you can either think of this as r over 100 with k in the denominator, okay? And if you take like 6% interest, then you would put 0.06 over k. And when you put 0.06, you're already dividing 6%, which 6 is a whole number, divided by 100, and that's why you get 0.06. Okay? The other way to do it is you think of it as r over 100k, which is the same thing, and you just put 6 on top, and then you put 100k on the bottom. Okay, and then you still end up, after you do 6 divided by 100, you still end up with 0.06k. Okay, what you should not do is you should not think of r as 0.06 already and then divide by 100 and make a super small number. Okay, so be careful. R should be the percent number, so if it's bigger than 1%, it'll be a whole number or a number that's bigger than 1%. Okay, and remember k is the number of times you compound, so it's either 1, 2, 4, 12, 365, depending on if you compound every year, or if you compound twice a year, or if you compound quarterly 4 times a year, or monthly 12 times a year, or daily 365 times a year. Okay. Alright, so for the first thing I gave you was a bunch of problems with different currencies and different interest rates, different k's, different n's, but these aren't hard. They're just you just need to identify which is which. So remember that the starting balance is PV in the formula, and the nominal annual interest rate is R, and the compounding frequency is K, which is going to be 1, 2, 4, 12. Number of years that the money is in the bank would be N. And to set up the calculation, you use the formula that we just went over. Okay, remember to be careful about R over 100. R over 100 you can replace with 0.06, 0.05, 0.12, but if you're going to put a whole number in for R, make sure you leave the 100 there. And if you put in a decimal, then make sure you take the 100 out. Okay, and the final balance is future value. Okay, so let's take the first example, which is 20,000 yen. And we are going to have a 1% annual interest rate compounded annually and for 10 years. So you can see that the 20,000 goes here, and the 1% can be changed to 0.01 because R over 100 is equal to 0.01. So that's R over 100 is 0.01, and then we'll divide by 1 because K is 1. And the exponent is going to be 10 because it's n times k, 10, right? N times k. And if you put that in your calculator, and this is the trickiest part, to put this in your calculator, let's multiply that out on the calculator. So, okay, watch me do this. Okay, so let's do this. 20,000 times, now 1 plus 0.01, you could put it as 1.01, but we'll go ahead and do with parentheses just to show you how you do that. So 1 plus parentheses 0.01 divided by 1 parentheses parentheses, and all that is to the exponent of 10, right? Okay, and you get 22,092.44. So that's what we have for Japanese yen here. Okay, then we take the example where it's $100 with 3% annual interest compounded quarterly, and N is 4 because it's 4 years. So if you do that, then we have 100 on the left side, and then we have 1 plus 0.03 over 4. Why 0.03? Because it's 3%. 3 divided by 100 is 0.03. Quarterly is 4, so we put 4 on the bottom, and N times K is 4 times 4, they're both 4. So if we put that in the calculator, we'll do it with parentheses very carefully, just to show you how that works. So 1 plus 0.03 divided by 4 And to make that more clear, we should probably put that in parentheses. So we'll put, we'll insert parentheses here. Okay, and then go to the other side and put parentheses, and then to the exponent, 4 times 4 is 16, right? So I don't need to put 4 times 4, I just put 16. So that's $112.70. Okay, that's the answer we got here. So now the next one, it's 600 reais, 15% annual interest, compounded monthly, and for 2 years. So that's 600 times 1 plus 0.15. Why 0.15? Because 15 divided by 100 is 0.15, and divide by 12. If you have difficulty automatically doing 15 divided by 100, I recommend that you just put 15 in there and put the 100 in there and multiply it out. So n times k, which is the exponent, is 12 times 2. Okay, compounded 2 times a year, or compounded monthly, which is 12, and for 2 years. So that would be, I'm going to show you a different way to put in the calculator. You could put 0.1, oops. We'll start with 0.15 divided by 12. And that'll give us the fraction. It's 0.0125. Then we'll add 1 to that. Okay, 1.0125. Now we're going to take that to the exponent of 12 times 2, which is 24. Okay, and that'll give us 1.347, and then we multiply that times the original amount, which is 1200. Which one am I doing now? Times 600, right? 600. So it's 808 reais and 41 centavos. Okay? Now the last one, we got 1200 euros, we put that there. 6% is R, so we put that there, but of course we already divided by 100. 6 divided by 100 is 0.06, but as I said, if you have trouble doing that, go ahead and put 6 over 100 inside the formula. 7 years compounded semi-annually, so it would be 2 times 7 n times k, and remember k always goes in the bottom here also. Okay, so we'll do it the second way with calculator again. So we'll do 0.06 divided by 2, and then we add 1.03, and then we take that to the power of 14. And we get that, and then we multiply times 1200, which is the original value, and we get 1815.107. So that is in euros. 1815.11 euros. Okay, so now we are done with number 1. We'll go on to number 2. Okay, so we're going to find the balance at the end of the year of $99 compounded monthly at an 8% annual interest rate. Okay, so we put 99 in for the original amount. 1 is always 1. We put 8% is 8 over 100, which is equal to 0.08. Do it on your calculator if you need to. So then we put 0.08 in the numerator, and the bottom at k is 12 because it's compounded monthly. And nk is equal to 12 times 1 because 12 is k and 1 is n. Okay, and so we'll do this in the calculator using parentheses and everything. So 1 plus 0.08. Let's put parentheses in there. 0.08 divided by 12 to the power of 12 times 1, which is 12. Enter. 107.22. 107.22. So the answer is 107.22. Okay, so that is $107.22. Okay, the interest added by the end of the year is what percentage of the original balance? This is the effective annual interest rate. So all we need to do is, in the numerator, we're going to put 107.22. In the denominator, we're going to put 99. So we already have 170.22 basically in there, so we'll just do divided by 99. and that gives us 1.083, 1.0830. Okay, and so now how do I change that into the annual interest rate? Well, this is equal to 108.30%. Okay, how we get that is we just multiplied the 1.083 times 100. And of course that's not the interest rate. The interest rate is the additional. So like 100% is the money you started out with. They're not giving you more money than you already started out with. They give you back exactly what you gave them, and they give you 8.3% more. Okay, so whatever's over 100 is going to be the amount of the interest. So the amount of interest, the effective amount of interest is 8.380%, which is greater than the nominal interest rate of 8%. Right? That makes sense. Whenever you compound you more often, that means that you're going to raise the amount of interest a little bit. Okay? Now find the balance at the end of the year of $101 compounded annually at 7% annual interest. So here we set up the formula. We start out with 101 and we multiply times 1 plus 0.07. And k is just 1 because it's compounded annually, and the number of years is just 1 also. So basically this is 101 times, and if you look at this, it's just 0.07 divided by 1 is 0.07, plus 1 is 1.07. Okay, so 101 times 1.07 is, we'll do that on the calculator, 1.07 times 101 equals 108.07 dollars. Okay, and so find the balance at the end of the year of $100 compounded semi-annually at an 8% interest rate. So the difference here is it's 8% instead of 7, so we have 8%. Semi-annually, k is 2, so we have 2 there and 2 there. And the beginning balance is $100, so it's 100 there. Okay, so let's do this one. So that's equal to 100 times 1 plus 0.08 divided by 2 and to the power of 2. Okay, so the answer is $108.16. Okay, and so now it says the interest added by the end of the year is what percentage of the original balance, that is the effective annual interest rate. So over the 100 is the original amount, and so on top we're going to put, we could do it different than last time. What we'll do is say, okay, if it started with 100 and you get 108.16, the amount of interest you added was 8.16. So we'll put 8.16 on top, and this will give us the interest rate. So 8.16 divided by 100 is just 0.0816, and if we convert that to a percent, it's 8.16%, right? So the effective annual interest rate is 8.16%, which is a little bit higher than the nominal interest rate of 8, and that's normal because when you compound more often, then you get a higher effective interest rate. So which option, A, B, C, will have the largest balance and which will have the lowest balance? Well, this is just, we've already figured out the hard part. So one of them has 108.16, the other one has 108.07, and the other one has 107.22. So the worst one is A. A has $107, so that's the lowest. So the lowest is A. And the highest is the one with 108.16 or 108.07. 108.16 is a little higher. So C is the highest. Okay? Alright. So I think that is number 2. Alright. And I'm going to have to continue in the next video because we're getting to 15 minutes. I am just going to take this quick opportunity to show you the Halloween costume that I used the other day. Some people didn't see me, and I promised that I would send a picture. Instead of sending a picture, I will just show you at the end of this video. So whoever was studious enough to watch this first half all the way to the end, here you go.